All right, so good morning. And so this is a numerical which is about circular motion, but utilizes the concept of vectors. So if you see, you have a body in circular motion like this, and the body has constant velocity. The body undergoes a change of angular displacement of 2 pi by 3, okay, which is equal to 2 by 3 into 180 is equal to 120 degrees. The body moves with constant velocity. So assume this is the place from which the body started, and then it moved an angle of 120 degrees. So here is the direction of velocity, and if you see 120, this is 180 degrees, and this is 90 degree, and this is okay. So that's your okay. So that's the angular displacement of the body. So angular displacement is basically the angle by which the body moved in the circle, right? It is represented by theta. The circular motion we have studied so far, we have not got into details of circular motion from the point of view of this type of question, because some of it is residing in the areas of when we do rotational motion. Anyway, so if you look into this, this is 120 degrees. This is known to you. Now, on a coordinate system, if you see, the velocity is in x-axis direction, and the velocity here is, in some direction. The question is, what is the change in velocity? Now, it is given that the velocity is constant. Therefore, in a constant velocity case, the velocity will change only because of change in direction. Okay, so you have velocity in this direction, which is x direction, and now the velocity is in some other direction. So if you were to break this down, velocity, which is your velocity after the displacement of 120 degrees, you can split the velocity as two components like these, right? So you have one velocity which is in the negative x-axis, and the other is negative y-axis, whereas this is purely x-axis. So if we have to solve this question, what we have to do is we have to write this velocity in a vectorial form. Okay, and we know this is perpendicular to the radius always. So what should be the vector form of this velocity is the question. And if you can see, if I break this down into two parts, I will get this part as the x part, and this part will come out to be the Vy. So you have Vy and Vx. So you can split the body, and you can extend this here, right? And you can draw a line parallel, or maybe you can just resolve this. And if you have to find what is the angle being made by this velocity vector, the velocity vector, you just extend it back, right? Because it is tangential. This is your x-axis, and this is the angle you get, right? The velocity vector is in some quadrant. You can see first, second, third, fourth quadrant, and the velocity is in this direction. So you can see this angle is given to be 90 degrees. This is 30 degrees. This is 90. So this will be 60 degrees. Okay, so you can decide this to be 60 degrees, and then you can take the components of the velocity, which is v. This velocity component is minus v sine 60, and this is minus v cos 60 degrees. So you know the velocity components now, and you have to calculate the change in velocity. Now, change in velocity here is happening because of change in direction. So your initial, final velocity at an angular displacement of 120 degree can be expressed as minus v sine 60 j minus v cos 60 I. Okay, and then your v initial is I have taken this to be, in some arbitrary direction, which is parallel to x-axis. So this is your VI. So if you have to find the change, it is VF minus VI given as minus V root 3 by 2 J minus V by 2 I minus V I. So if you want to calculate the magnitude, obviously these two will become minus 3 by 2. So this will become minus root 3 by 2 whole square plus V by 2, you can write this as 3 by 2 whole square. And then of course, because we're finding the magnitude, this is what it becomes. And therefore you get 3 by 4 plus 9 by 4 into V square. So 9 threes are 9 plus 3 is 12. So this will fetch you 12 by 4 V square, and this will give you root 3 V. So the change in velocity in uniform circular motion, where the velocity throughout the motion remains same, is given by thus the subtraction of the two vectors. Right? So I think the problem in this question is one, you need to have in-depth understanding of vectors. Okay, that's I think primarily the focus of this question, because uniform circle, it is very well known that the velocity magnitude is same throughout. So if velocity magnitude is same, it is same everywhere. Obviously you need some more knowledge of the concept of angular displacement and how do you utilize the angular displacement to find the direction of this velocity vector V final. Requires some sort of knowledge of circular motion, which we have not done to an extent. We have done some concepts of centripetal acceleration, but when you have angular displacement, angular acceleration, when we start rotational motion, definitely we will go in that side also. So circular motion falls in straight away the which is the centripetal, and the other part of circular motion is in the the rotational motion. And then we of course do the vertical circle and non-uniform circular motion. But I think this question was bit away from what we have done so far, and also from vectors point of view, it tested your knowledge of vectors. So I hope this helps. Please go through this and don't be disheartened, because I think most of the questions are centered around the concepts of circular motion, which we learn as we move into rotational motion. Thank you very much.